Hello students, this is Radhika Patel going to teach you chapter number 5, that is transport and application layer in mobile IP. Right, now let's see the content of the sub chapter. The chapter contains TCP mechanism wherein you would be learning about classical approaches of TCP. Inside that you would be learning about indirect TCP, spoofing TCP and mobile TCP. First of all, let us learn about what is traditional TCP. First of all, TCP, that is transmission control protocol, that is the protocol of transport layer. Along with TCP, there is one more protocol, that is UDP, user datagram protocol. But the TCP is the most used protocol at the application layer for the applications. Now let us first talk about traditional TCP mechanism. The very first functionality provided by TCP is congestion control. Moreover, this TCP is stream oriented and not transaction oriented, and it is network friendly, but it gets timeout when it gets timeout, that is when there is a congestion and when there is a slowdown transmission. Now let us know about what is congestion. Congestion, that is whenever there is a number of more packets in the queue. The term used for this in the communication channel is known as congestion. Now to overcome the congestion, the work done is, that is slow down transmission. Now what it is very well known that TCP wrongly assumes that congestion in the wireless and mobile networks is done when there is a packet loss due to transmission errors and when there is a packet loss due to change of network. As a result of this, there is a severe performance degradation in the network. Uh, to overcome the congestion, there is a mechanism that TCP does, and that is known as slow start. The reaction TCP shows after detecting the congestion is slow start. Here, the sender always calculates a congestion window for a receiver. Start size is always one segment, that is one packet. After receiving the acknowledgement, sender increases the window size. The window size increases exponentially, but at a particular point, it is very dangerous to double the congestion window. Congestion window size can't be increased beyond the congestion threshold value. After the threshold is reached, window size can only be increased linearly, and that is equal to 1. Fine. Now let us know more about traditional TCP. Traditional TCP is basically designed for fixed end systems and fixed wire networks. As we know that what was there in TCP slow start algorithm. Now to overcome that, after TCP slow start algorithm is done, there is one more traditional TCP mechanism that is carried out, that is TCP fast retransmit. Now here TCP sends an acknowledgement after receiving a packet. If the sender receives continuous acknowledgement of the packet that is received from the receiver, the gap in packet stream always can't be due to congestion, but it can also be due to the transmission error. So the sender sends the accused packet that is and this is known as fast retransmit. Other reason for activation of slow start can be timeout due to missing acknowledgement. Here TCP uses fast retransmit and fast recovery, and it interprets that it is due to congestion, and so it activates the slow start mechanism. The conclusion is that the packet lost is not due to the congestion, so retransmit the packet and continue with the current congestion window, but do not use slow start. TCP assumes that congestion of the packets if the packets are dropped. In wireless networks, the concept is false because here we often have packet loss due to transmission errors. Moreover, mobility can also cause packet loss. For example, mobile node roams from one access point to the another, and for example, for an agent in mobile IP. Well, packets in transit to the old access point and forwarding is not possible. Now, let us move towards the third mechanism, that is known as indirect TCP. Here, mobile host, if connected via wireless link access point and that is connected to a wired internet. Here in this figure, it is shown that there is a wired connection between an access point, that is a foreign agent, to the personal PC. And the same time, there is a wireless TCP connection between the access point and the mobile host. Standard TCP is used between the fixed computer and the access point. Instead of mobile host, the access point now terminates the TCP connection, acting as a proxy. The correspondent host in the fixed network doesn't notice the wireless link. The foreign agent here acts as a proxy and relays all the data in both the directions. If correspondent node sends the packet, the foreign agent acknowledges it and tries to send it to the mobile host. If the mobile host receives the packet, it acknowledges the packet to the foreign agent. The corresponding agent node doesn't recognize this. Now, the drawback of this indirect TCP is segmentation of single TCP connection into the TCP connections. This loses the original end-to-end TCP semantics. To overcome the same, the enhancement of the TCP is done where buffering and data close to the mobile host is done to perform the fast local retransmission in case of the lost packet. In this approach, the foreign agent buffers all the packets with destination mobile host and snoops the packet flow in both the directions. This is known as snooping. The reason for this buffering is to enable foreign agent to perform local retransmission in case of packet loss on wireless link. The foreign agent buffers the packet until all the acknowledgement is received. Data transfer from the mobile host with destination correspondent host works like the foreign agent snoops the packet streams to detect gaps in the sequence of TCP. As soon as the foreign agent finds the missing packet, it returns negative acknowledgement to the mobile host. The mobile host will now retransmit the missing packet that are in the communication network.